send that out to the people on the distribution list. Today, we're going to be talking about data model fundamentals, and we have Vlad Lebedev and Jacob Rab. And before they start, Cheryl, did you want to say anything?
I just want to say welcome everyone as we rejoin based on our quarantine slumber. I think this is an exciting topic in terms of data model fundamentals. Vlad, as our chief architect, has a lot to say about the database theory behind the Limfinity data model. And I'm sure you'll enjoy Jacob as he digs into some data model code samples. Again, thank you for joining us. Vlad?
Yes, thank you, Cheryl. Can everyone see my screen?
Yes.
Yes.
Yes, excellent, excellent. Well, I really want to start with a couple of announcements. And I don't know if you know, but this month is actually 1 year anniversary of our developers webinars. So we are, in a sense, entering season 2. And we do have some very exciting content for you. In September, this month, today, we're going to talk about data model fundamentals. And later in the year, we want to revisit such topics as single sign-on and authentication on Limfinity. We want to dive deeply into how we work with file attachments, what is possible for file processing, different types of files, how we can do it in the script and in the UI. And another popular topic that was requested is how we can customize grid displays. Can we add icons? Can we do conditional displays? Can we do color highlights, fonts, pretty much all that. Additionally, if you have a specific topic in mind you would like us to cover, or maybe you would like to be a presenter, drop us an email either to me or Monica, and we can make that happen. Anyways, the topic for today is the most fundamental topic of them all, basically the data model. Everything starts with the data model, and depending on how well it's designed and how well it's organized in Limfinity, that's going to pretty much define what's going to happen next. All the workflows, all the permissions, everything else, they all start and flow from the data model. So today we want to cover some basics, look behind different options that are available in the framework. We're going to look at the different database types and compare that to how we engineered Limfinity to handle both complexities and simplicities. And Jacob is going to show you some UI and some code samples, and then we are available for Q&A. Well, realistically, if you look at all the databases that are out there, commercial, open source, pretty much all of them, they're going to be divided into two big major categories. They either relational database or non-relational database. And all of them, they have their strengths and weaknesses. Relational databases are those big, well-known names like Oracle, Postgres, MySQL, Microsoft SQL Server, many others. The advantage is that they have a clear, strict schema. And the data that's going to be stored in those databases, they all properly structured. The weakness lies in the strength that same schema can be quite complex, and those schemas and constraints makes it pretty much impossible to scale horizontally. So you cannot increase the number of machines, increasing the performance. You can only scale vertically with those databases, increasing the power of a single machine. The non-relational databases, on the other hand, they can be quite specific. There are a whole lot more of them available out there, including databases from AWS, Google, and others, Dynamo, Neo4j to store graphs, databases to do elastic searches, CouchDB to store key value pairs. The advantage is that they schema-free, so to say. So you don't need to define a schema in advance, and that allows to very, very easy horizontal scaling. The bad thing about them that same lack of schema makes the data sometimes unpredictable in that database. Additionally, it's very hard to access that data and do updates. So for example, to access a key value pair database in CouchDB, you need to have a key. If you don't know the key, well, you have to search for the key first. So when it came many years ago, when it came the time to design how we want the data to be stored in our system, we really took the best from both worlds. Limfinity model is built on top of the relational databases. Right out of the box, you can work with Oracle, Postgres, and SQL. But you really don't need to define that schema in advance. And I'll talk more about that, but we eliminated pretty much all the bottlenecks that comes with that schema. Key maintenance, index maintenance, and complexity of the schema, it's all well hidden within the UI. Additionally, we want to take the best what's available in non-relational databases. For example, our data model is a graph like a Neo4j of sorts. It gives you a nice way to search and access data throughout the graph. And we also have ability to work with key value pairs and do searches like that. Also, traditionally, in relational databases, there are quite a few types of relationships. The most common one, well, the simple one is one-to-one, basically, when an entity in one table refers to an entity in another table, like country can have a capital, for example. Or one-to-many, when patient has many samples, many-to-one, when many lab tests can be done on a single instrument, additionally many-to-many, many lab tests on many different instruments. Traditionally, when we're talking about those relations, they usually represented in what is called ER diagram, entity relationship diagram. For example, here I can represent employee and job history. That means that line means that this is a required relation and this is one-to-many. There are optional relationships that are required. So in Limfinity, we decided to simplify that and simplify that a lot. Basically, replace all those possible type of relationship with a single relation, which is called, we're going to get to that later on, which is, you're probably aware, this is the user-defined field of type subject. So that single user field replaces all possible types of relations in the system. Additionally, it's important to distinguish relations versus properties. So for example, country having a capital and patient having a primary physician, it can be viewed as both a relation and a property. Again, in Limfinity, we also try to get rid of that relation, that knowledge, that distinction. So every time you're working with the subject user-defined field, you realistically don't have to worry what it's going to be. It can act as both relation and a property. Furthermore, there is a third case available, which is known as associative entity, where, for example, you use the intermediate table to connect to other tables. In our example, patient is scheduled for the test, and the scheduled part can have its own properties and attributes like a place where the test is going to be taken and the time of the event. Again, with the Limfinity, this is all replaced with a single user-defined field of type subject, which can act and help with creating those associative entities. That's where the graph idea kind of really comes into place. I really wanted to explain that whole concept a little bit further. So there is a single user-defined field of type subject that takes care of all relations in the data model. And you want to look closely at the very simple case where patient have multiple samples. So you can define a subject type patient, first name, last name, all the attributes, and you can define the subject type sample, volume, units, sample type, and you have a separate subject type to store volumes, and a separate subject type to track the type of sample. What is interesting that in my example here, the sample has a reference to the patient, and the patient have a reference to the sample. And I'm going to explain the concept of this back reference a little bit here when we put everything together in a kind of realistic graph view. By having a single field of type subject on a sample level, we establish a link to the patient. And by having a property sample type and volume units directly on the sample, we establish a link to volume unit and sample type. So that link on top acts as a relationship, and those two links act as a property. Again, from the Limfinity point of view, you don't have to worry about how that's going to be stored inside the actual database. And from the engineering point of view, quite simple to put this together. Additionally, we have another type of user-defined field, which is called back reference. And this is more like a formula, automatic formula field that will return you a counter. How many times that object, which is patient, which sample, has been referenced back. So that means when I put a back reference type user-defined field on the patient, it's going to be of type sample, and that allows the system to automatically calculate all references from sample to patient. So I have 20 samples from that patient, it's going to show me a count of 20. Theoretically, the same concept can be expanded further. And for example, I can use them on the property dictionaries as well. If I'm looking at the sample type, the same user-defined field can be added to the sample type, and now it's going to calculate how many samples of certain type available in the system. And same goes to volume units. There is another very interesting case that traditional databases have a little bit of struggle implementing, and non-relational databases do quite well. So this is what is called the polymorphic property. Let's look at a couple of examples. A very simple case when I have a sample and there is a derivative from that. One way to represent that in the data model, if you have a sample, patient, sample type, volume unit, nothing changed. And then we have two additional subject types, DNA sample and RNA sample. They both have reference to the parent sample. So this is the traditional way of doing that. And if I want to replace that with a property and have a polymorphic property, it's going to look a little bit different. Additionally, for the demo, there is a couple of back reference fields. So using the same schema, I can clearly see how many derived RNA samples and how many derived DNA samples are out there. So now I really want to show you how to do it differently. And let's imagine that there is a new case where we have a single derived samples property on a sample. And we want to use that field to store either DNA sample or RNA sample. I can remove that parent sample link because it's no longer needed. And derived sample becomes a formula type UDF to calculate how many of those need to be. And the third case would be when derived sample is actually a polymorphic property. This becomes a subject UDF of type that refers back to DNA sample and RNA sample. So again, you can see that DNA sample and RNA sample, they no longer have a reference back to that original sample and instead can have their own properties specific to DNA and RNA. And Jake, we're going to show that how, based on different subject types, you can access the data graph and get straight to those properties. So I think that's pretty much covers it. I just want to reiterate that all traditional complexities is hidden in Limfinity. So you don't have to worry about any of the database keys. And when we talk about indexes that traditionally used to define constraints on the data or help with the searches, make it a whole lot faster, Limfinity takes care of all indexes for you. Constraints are defined separately in the UI under subject constraints. You can have a lot of flexibility how you want to have that done. And realistically, you no longer have to worry about null values in the indexes, about frequent insert update operations and other restrictions. And Limfinity takes care of all the index maintenance for you. So rebuild, database vacuum, all that can be scheduled without downtime and on a certain time schedule. So realistically, I'm pretty much done. And now back to Jacob, to show you more of how that's going to look in the system.
Thanks, Vlad. Are you able to see my screen?
Yes. Yes.
Okay, great. So I'm going to go through some of the examples that Vlad has had in his slides to show you what that looks like in the system. First of all, the simple example of many-to-one relationship. In this example, we're working with the patient and sample subject types, and a sample has a single patient. Patient can have many samples. So the way this is set up is by adding a patient field to the sample subject type. You'll just go under the user-defined fields, pick the subject type, name it something like patient, and select the appropriate subject type for it. I've already set that up in this case. And this is what it looks like on the subject type itself here. And in the database, the way this manifests is that when you're adding a sample, you have to pick the patient, right? So you're choosing which patient it's for. We can go through the exercise also of adding the back reference. This is pretty handy when you need to be able to see for a given patient. Let's look at all their samples. We can go here under Limfinity, choose the subject back reference type, pick some kind of name for it. You could choose the name sample. You could also choose something that's a little bit more descriptive, such as patient samples. And you pick the subject type that it's of. And now when I go visit that patient, I can see there's a list of samples here. This was created automatically by the system. No need to do any extra work. People keep saying that there's code examples, but there's really no code even involved in this at all. And you can see a list of samples that patient's involved in. So that's the many-to-one relationship. Now I'm going to show the polymorphic one. I already have this set up to work with the case that Vlad mentioned first, which is where the DNA sample and the RNA sample, they're both derived from the sample, and they have a parent sample field. So they link to it's basically treated like almost like a traditional many-to-one, except you have two different subject types, which have the parent sample field. So this works, but what this means is that if we want to see which derived samples there are, we've got to use two different back references here, the derived DNA samples and the derived RNA samples. And the way this looks in the database, if you go to a sample, you can see it's got derived DNA samples, derived RNA samples. But let's say you want to change this a little bit and use a polymorphic field instead of doing this. This can make it a little simpler. It can change. You can adjust your data model to make it to make this a single field, for instance, tracked on the sample itself. So in this case, I'm going to make it a list that is subjects of several types, called derived samples. Pick the DNA sample and RNA sample type, meaning the list can hold both, and click OK. So what this does is, if I'm on my sample here, create a derived sample. I have just made this little tool for the demo purposes. Oh, I was supposed to call it child samples. Whoops. Sorry. just change the name real quick, child samples, because that's what it is in my tool. Okay. So create a derived RNA sample. And you notice here it shows up right here, child samples RNA sample 3. I could do the same thing, create a DNA sample. It's in the same list. And this one, the downside to this is that you can't render multiple subjects of the different types in the same grid. So this is not a link, it's just a counter. It can be simpler, but it's not quite as flexible in what it allows you to do. Okay, so for the final example, I want to show, and also, we could do the same thing, setting up the back reference on here. Right now, parent sample is a subject, but, let's say you want to create a back reference that shows where it came from. You can do that as well. I'm going to call this originating sample to differentiate it from parent. For my strategy 2 here, make it a sample subject type. And now if I go to one of these DNA samples that I just created, doesn't seem like it's working for some reason. I'm not exactly sure. But let's move on from that, and I'll show you the final example, which is a many-to-many relationship. For this example, we'll be using patient and medication. So in a traditional database layout, you would need an intermediary table to capture the fact that a patient can have multiple medications and a medication can be used by multiple patients. In Limfinity, you don't need that intermediary table. All you have to do is choose which of the two subjects is going to kind of host the other one. It's an art rather than a science, what you're doing this, how you choose this. But in this case, we can kind of think about it. In real life, it makes a lot more sense that a patient would have multiple medications than the other way around. Even though both are true, even though, a medication is used by multiple patients, it makes a little bit more sense. We think about it as a patient with multiple medications. So the way we're going to capture that is by adding a new field here, subjects. And we can call this something like patient medications. And the subject type is medication. The way this manifests in the database is that, let's say we're adding a new patient. Oops. Adding a new patient, John Doe. We can choose his medications here and choose multiple values. And just like in all the other examples, you can add a back reference too, because you may want to know which patients are taking Tylenol. So in order to do that, you just simply add a back reference, and we can call it something like patients using medication. Link it to patient. Click OK. And now if we open up the medications table and we jump on the Tylenol, or did I pick that one for him? Vlad, did I mess something up?
Yes, Jacob, it's not going to work like that. It has to be a link.
Oh, it has to be a direct link?
Oh, yes. To calculate what you're looking to do, you got to have a formula UDF. Right,
formula UDF. Okay.
Mm-hmm.
Right. So in order to do this, we actually need a formula UDF, not a subject back reference. So here we can set up a new formula UDF. Actually, real quick, I'm just going to delete my first attempt at this.
Jacob, maybe you can show that how we can render the model graph now that you have your data model.
Yeah, that's a good idea. Okay. So this is pretty simple. It's on your list of subject types. You can jump straight to a graph showing what this looks like.
But you're using your local machine, Jacob, right? Not an instance.
Yeah. So you may switch to an instance and show that real quick.
If you're running like a developer version locally, without any tools, you're not going to see the graph.
Right. I don't have the proper license, right?
But doesn't matter. I mean, for production systems, every time you change in the data model, you can click that icon and it will be updated on the fly.
Right. So this shows if you click this item in this icon in a normal Limfinity instance, not on a local machine, it will render a whole graph that shows you, basically just like Vlad's slides, the links between the tables and all of the relationships. You want me to show that for like lists or something?
Well, I mean, I think that's good enough.
Okay. All right. Do we want to go to questions?
Yes.
I guess first of all, any questions about anything I had on my screen? I can reshare if we want.
I just had one quick question. On the subject back reference, there's a field for list expansion threshold, and I was wondering if you could talk about what that is.
Oh, I can do that.
Oh, you want to go ahead and take that? Okay.
Go ahead.
Okay. List expansion threshold. Let me share my screen again. Let's see. All right, we're seeing Limfinity. So the way this works is that if you here, I can actually edit one of the user-defined fields and show you. For instance, patient medications. This is not a back reference, but it does have the same property. What this will do, if I change this, you'll notice that currently, when we view that patient, you'll see on his list of medications, it's just a 2, and you have to click it to see the grid, right? But if I update the list expansion threshold on patient medications to, let's say, 2, that will show both values when we actually view the patient. So that can be handy when you have fairly short name for your items. So you notice here that it shows both Advil and Allegra spelled out. And you can click one of them. You don't have to view a grid. So fewer clicks. It can be handy when you have pretty short names for the subjects, and you there's only a very small number of them. Or maybe there can be a small number or a large number, but in the cases where there's a small number, you want the user to be able to easily get to the items themselves.
Great, thanks.
No problem.
Hi, Jacob. This is Chandra. So when you have this grid reference like this, you expand it. So in the grid, it's only in the record detail page you will see it, not in the grid. Will you? Oh, you need to remove your personal preference in the grid view, I think. Oh, there it is. Yeah. So it will only show numbers still.
Yes, but if you click that row expand on the left.
Yeah, the reason I'm asking is like when you are generating a report or something, there is a problem when you have multiple references or multiple subjects. You can't have the name of it. It's always going to be showing as a number, even if you have it expanded it.
Yeah, you can expand that through use of formula field, and then you can control that more precisely.
Okay, so you need to have a formula UDF for that. Okay, thank you.
Yep, you could create a formula that just returns a string, where the string is the list of each name in the concatenate all of the names of the medications, for instance.
Thank you. Makes sense.
All right. If there are no more questions, back to Monica.
I had one more quick question, if that's all right. This is Christopher again. So Vlad, you were talking about a little bit about indexes, and when you examine some of the elements in the Limfinity database, they all have UUIDs on them. Could you just briefly describe how you use the UUIDs to make indices, or if that in fact is the indice?
No. Indices are a separate piece. Basically, UUIDs allow us to uniquely identify a record across multiple instances of the same system. When we're talking about a development cycle, when you have your development instance and then test, QA, production, our bricks technology that moves configurations separately from the data from one instance to another relies on those unique IDs to kind of uniquely identify that record across multiple instances. For indexes themselves, you should look at maybe a good example would be on the subject table that subject names, for example, is an index that allow us to do quick searches. When you go to quick search in the UI, you type something. I mean, naturally, it relies on indexes to deliver that search.
Indexes you're updating in the background between potentially multiple users, etc.
Yes, that's one of the latest features in the latest releases of the databases from Oracle Postgres. Normally, we put it on a schedule, so sometime in the midnight, when the usage is low, we can dynamically update all the indexes.
Great, thanks. That makes sense.
I guess back to Monica.
Well, thank you everyone for joining us, and we'll look forward to next month. And please reach out if you have any suggestions for future topics or if you have any questions. Cheryl, did you want to say anything?
Just want to say thank you to everybody for joining us, and we do encourage you to, as Monica and Vlad mentioned, send in any topic ideas that you have. And have a great day. Thank you.
Okay, thanks everyone.
Thanks.
Thank you.
Bye.
Thanks, Vlad and Jacob.
Bye.
Bye.